Next, we are going to measure the filtration properties of a fluid. We already have a sample, and we have the filter press, the API filter press. We are going to make sure that it's properly assembled. And here we have the components of a filter press. To this, I have to put this screen, and then the filter paper, and then a little ring as a packer here. And this ensemble is ready to go. Now I can put the main cylinder so that I have a container where I can put my fluid. And I'm going to fill it up more or less until ½ an inch of the top. So here is our mud sample, and we can start putting this here. And the next step would be for me to cap it and apply the pressure so that filtration will start taking place. I'm going to be collecting the filtrate in this graduated cylinder, and I'm going to adjust this so that I can work more comfortably. Now, to assemble this, we are going to first put it in place. Then we are going to apply pressure to get a good seal. Now we need a CO2 cartridge, which we are going to use to obtain 100 psi pressure. So I'm checking my valves here to make sure that it's okay for me to go ahead and puncture the cartridge so I can use the pressure inside. Be able to feel when I'm touching that, and then I'm going to go ahead and rotate about half. Now what I'm going to do is apply 100 psi, and we are ready to pressurize. And you can see the indicator going all the way to 100 psi, according to this gauge. I believe we are there. Having applied the pressure, I'm going to reset this and start measuring 30 minutes. And what's going to happen is we are going to be collecting the filtrate. You can see that there is some dripping here. The filtrate is going to be useful to measure chloride's hardness, that is calcium and magnesium. Most of the hardness in a drilling fluid is going to be calcium, and part could be also magnesium. And then also we are going to measure alkalinity of the filtrate. In addition, we can use the filtrate to measure the pH. So now we have to wait 30 minutes, and meanwhile we can see that we are collecting a sample that is of an amber color. And we have to measure how many cc's we collect in 30 minutes, and then we are also going to take a look at the quality of our filter cake. After the experiment, we are going to be opening the device and removing the filter paper and taking a look at the cake that is on top of it. It's been 30 minutes and we are ready to remove the pressure and release it, and then measure the filtrate in cc's and take a look at the filter cake. I'm going to open some valves, 100 psi all the way down to 0, gently. First thing I can see here, make a reading, and I can see that we have 5.8 cc's of filtrate. Now I'm going to proceed to disassemble this and take a look at the cake. The fluid which is inside the press can be reused, so I'm going to put it back here. And here is my cake. And take a look, and it's flexible And thin looks like a very good one because we got a pretty low filtrate. Actually, that was 5.8. That's kind of low. Anything below 10 can be considered good filtration control. As a matter of fact, I could even measure this using a very practical ruler, and I can measure this in 30 seconds. I sink this into the cake and take a look, and it comes to approximately 2/30 seconds of an inch, which is something I would expect from a very good quality cake. It's thin, therefore it's impermeable, and actually we know that because the filtration was very low. It was only 5.8. That's an indication that the filtration properties of this fluid are very good.